Homo erectus is an extinct species of hominid that lived throughout most of the Pleistocene geological epoch. Its earliest fossil evidence dates to 1.9 million years ago and the most recent to 70,000 years ago. Its extinction is linked by some scientists to the Toba supereruption catastrophe, but no sufficient case has been made to date for the idea. It is generally thought that H. erectus originated in Africa and spread from there, migrating throughout Eurasia as far as Georgia, India, Sri Lanka, China and Indonesia. But other scientists posit that the species rose first, or separately, in Asia. Debate also continues about the classification, ancestry, and progeny of Homo erectus, especially vis-a-vis Homo ergaster, with two major positions. 1. H. erectus is the same species as H. ergaster, and thereby H. erectus is a direct ancestor of the later hominins including Homo heidelbergensis, Homo neanderthalensis, and Homo sapiens, or 2. It is in fact an Asian species distinct from African H. ergaster. There is also another view, an alternative to 1. Some paleoanthropologists consider H. ergaster to be a variety, that is, the African variety of H. erectus, and they offer the labels Homo erectus sensu stricto for the Asian species and Homo erectus sensu lato for the greater species comprising both Asian and African populations. A new debate appeared in 2013, with the documentation of the Dmanisi skulls. Considering the large morphological variation among all Dmanisi skulls, researchers now suggest that several early human ancestors variously classified, for example, as Homo ergaster, or Homo rudolfensis, and perhaps even Homo habilis, should instead be designated as Homo erectus. Origin. The first hypothesis of origin is that Homo erectus rose from the Australopithecina in East Africa sometime during, or perhaps even before, the early Pleistocene geological epoch, which itself dates to 2.58 million years ago. From there it migrated, in part, by 2.0 Maya, probably as a result of broad desertifying conditions developing then in eastern and northern Africa. It joined the migrations through the Saharan plump and dispersed around much of the Old World. The fossil record shows that its development from about 1.8 Maya to 1 Maya was widely distributed in Africa, the Transcaucasus, Indonesia, and in Vietnam, China, and India. The second hypothesis is that H. erectus evolved in Eurasia and then migrated to Africa. They occupied the Dmanisi site from 1.85 million to 1.77 million years ago, which was about the same time or slightly before their earliest evidence in Africa. There are several proposed explanations of the dispersal of H. erectus georgicus, including whether or not Africa is the source, discovery and representative fossils. The Dutch anatomist Eugene Dubois was fascinated by Darwin's theory of evolution, especially as it applied to humankind. In 1886, he set out for Asia, which then was the region accepted as the cradle of human evolution, despite Darwin's theory of African origin. See Haeckel. Research to find a human ancestor. In 1891, his team discovered a human fossil on the island of Java, Dutch East Indies, excavated from the bank of the Solo River at Trinil, in East Java. He named the species Pithecanthropus erectus, from the Greek pi iota theta eta kappa omicron sigma, ape, and nu theta rho omega pi omicron sigma, man, based on a skull cap and a femur like that of Homo sapiens. Dubois' 1891 find was the first fossil of the Homo species found as result of a directed expedition and search, and which was inspired by Darwin's radical theory that humans, like all other species, evolved from ancestral species. See Human evolution. The Java fossil from Indonesia aroused much public interest. It was dubbed by the popular press as Java Man, but few scientists accepted Dubois' argument that his fossil was the transitional form, the so-called missing link between apes and humans. Java Man is now classified as Homo erectus. Most of the spectacular discoveries of H. erectus next took place at the Zhoukoudian project, now known as the Peking Man site, in Zhoukoudian, China. This site was first discovered by Johann Gunnar Andersen in 1921 and was first excavated in 1921, which produced 2 human teeth. Canadian anatomist Davidson Black's initial description of a lower molar as belonging to a previously unknown species prompted widely publicized interest. Extensive excavations followed, which altogether uncovered 200 human fossils from more than 40 individuals, including 5 nearly complete skull caps. German anatomist Franz Weidenreich provided much of the detailed description of this material in several monographs published in the journal Paleontologica Sinica. Nearly all of the original specimens were lost during World War II, however. Authentic casts were made by Weidenreich, which exist at the American Museum of Natural History in New York and at the Institute of Vertebrate Paleontology and Paleoanthropology in Beijing, and are considered to be reliable evidence. Throughout much of the 20th century, anthropologists debated the role of H. erectus in human evolution. Early in the century, due in part to the discoveries at Java and Zhoukoudian, it was widely accepted that modern humans first evolved in Asia. A few naturalists, Charles Darwin most prominent among them, theorized that humans' earliest ancestors were African. Darwin pointed out that chimpanzees and gorillas, humans' closest relatives, evolved and exist only in Africa. African genesis. From the 1950s forward, numerous finds in East Africa confirmed the hypothesis of an African genesis, providing fossil evidence that the earliest hominins originated there. It is now generally accepted that H. erectus descended from either 1. the earliest hominin genera, or 2. the earliest Homo species. East Africa provided sympatric coexistence for H. erectus and H. habilis for several 100,000 years, which tends to confirm the hypothesis that they represent separate lineages from a common ancestor, that is, the ancestral relationship between them was not anagenetic, but was cladogenetic, which here suggests that a subgroup population of habilis, or of a common ancestor of habilis and erectus, became reproductively isolated from the main group population, eventually evolving into the new species Homo erectus. In the 1950s, archaeologists John T. Robinson and Robert Broom named Telanthropus capensis. Robinson had discovered a jaw fragment in 1949 in Swarthkrans, South Africa. Later, Simonetta proposed to redesignate it to Homo erectus, and Robinson agreed. In 1961, Eve Coppens discovered a skull of Chadanthropus uxoris, then the earliest fossil human discovered in North Africa. It was reported that the fossil had been so eroded by wind-blown sand that it mimicked the appearance of an australopith, a primitive type of hominid, although at first considered to be a specimen of H. habilis. Uxoris is no longer considered a valid taxon, and has been subsumed into H. erectus. In 2013, a fragment of fossilized jawbone, dated to around 2.8 million years ago, was discovered in the Ledi Jararu research area in the Afar Depression, Ethiopia. The fossil is considered the earliest evidence of the Homo genus known to date, and seems to be intermediate between Australopithecus and H. habilis. The individual lived just after a major climate shift in the region, when forests and waterways were rapidly replaced by arid savanna, which was a domain favored by the early hominins. Homo erectus georgicus. Homo erectus georgicus is the subspecies name assigned to fossil skulls and jaws found in Dmanisi, Georgia. First proposed as a separate species, it is now classified within H. erectus. The site was discovered in 1991 by Georgian scientist David Lord Kapanidze. 5 skulls were excavated from 1991 forward, including a very complete skull in 2005. Excavations at Dimorphism have yielded 73 stone tools for cutting and chopping and 34 bone fragments from unidentified fauna. The fossils are about 1.8 million years old. After their initial assessment, some scientists were persuaded to name the Dimorphism find as a new species, Homo Erectus, which they posited as a descendant of African Homo habilis and an ancestor to Asian Homo erectus. This classification, however, was not supported, and the fossil was instead designated a divergent subgroup of Homo erectus. The fossil skeletons present a species primitive in its skull and upper body, but with relatively advanced spine and lower limbs, inferring greater mobility than the previous morphology. It is now thought not to be a separate species, but to represent a stage soon after the transition between H. habilis to H. erectus. It has been dated at 1.8 Maya. The assemblage includes one of the largest Pleistocene Homo mandibles, one of the smallest lower Pleistocene mandibles, a nearly complete subadult, and a toothless specimen D3444, D3900. 2 of the skulls, D2700, with a brain volume of 600 cubic centimeters, and D4500 or Dimorphism skull 5, with a brain volume of about 546 centimeters, present the 2 smallest and most primitive hominin skulls from the Pleistocene period. The variation in these skulls were compared to variations in modern humans and within a sample group of chimpanzees. The researchers found that, despite appearances, the variations in the Dimorphism skulls were no greater than those seen among modern people and among chimpanzees. These findings suggest that previous fossil finds that were classified as different species on the basis of the large morphological variation among them, including Homo rudolfensis, Homo gautengmensis, Agaster, and potentially even H. habilis, should perhaps be reclassified to the same lineage as Homo erectus. Classification and distinctions. Paleoanthropologists continue to debate the classification of Homo erectus and Homo ergaster as separate species. One school of thought suggests dropping the taxon Homo erectus and equating H. erectus with the archaic H. sapiens. Another calls H. ergaster the direct African ancestor of H. erectus, proposing that Erectus emigrated out of Africa to Asia while branching into a distinct species. Some scholars dispense with the species name Agaster, making no distinction between such fossils as the Turkana boy and Peking man. Still, Homo ergaster has gained some acceptance as a valid taxon, and the 2 species are still usually defined as distinct African and Asian populations of the greater species H. erectus, that is, Homo erectus sensu lato. Some have insisted that Ernst May's biological species definition cannot be used to test the above hypotheses, that is, that the 2 species might be considered the same. Alternatively, the amount of variation of cranial morphology between known specimens of H. erectus and H. ergaster can be compared to the same variation within an appropriate population of living primates, such that, if the amount of variation between H. erectus and H. ergaster is greater than that within an appropriately selected population, for example, say, macaques, then H. erectus and H. ergaster may be considered as 2 different species. Finding an extant model suitable for field study, analysis, and comparison is very important, and selecting a living sample population of an appropriate species can be difficult. But subsequent specimens showed their variation to be within the range of Homo erectus, and they are now classified as Homo erectus georgicus. H. erectus fossils show a cranial capacity greater than that of Homo habilis. The earliest fossils show a cranial capacity of 850 cc, while later Javan specimens measure up to 1100 cc, overlapping that of H. sapiens. The frontal bone is less sloped and the dental arcade smaller than that of the Australopithecines. The face is more orthognatic than either the Australopithecines or H. habilis, with large brow ridges and less prominent zygomata. The early hominins stood about 1.79 meters, only 17% of modern male humans are taller, and were extraordinarily slender, with long arms and legs. Sexual dimorphism in H. erectus, males are about 25% larger than females, is slightly greater than seen in the later H. sapiens, but less than that of the earlier genus Australopithecus. Regarding evolution of human physiology, the discovery of the skeleton of Turkana Boy, near Lake Turkana, Kenya, by Richard Leakey and Kamoya Kimu in 1984, one of the most complete hominin skeletons ever discovered, has contributed greatly to the interpretation. Interpreting evolution. H. erectus, H. agaster, H. sapiens, Stringer and Reed, al. and others have produced schematic graph models for interpreting the evolution of Homo sapiens from earlier species of Homo, including Homo erectus or Homo agaster. See graphs at right. Blue areas denote the existence of one or more hominin species at a given time and place. These and other interpretations differ mainly in the taxonomy and geographical distribution of species. Stringer depicts the presence of H. erectus as dominating the temporal and geographic development of human evolution, and as persisting broadly throughout Africa and Eurasia for nearly 2 million years, eventually evolving into H. heidelbergensis, H. rhodesiensis, which in turn evolved in H. sapiens. Reed, al. shows Homo agaster as the ancestor of Homo erectus, then it is agaster, or a variety of agaster, or perhaps a hybrid of agaster and erectus, which develops into species that evolve into archaic and then modern humans and then out of Africa. Both models show the Asian variety of Homo erectus going extinct recently, and both models indicate species admixture. Early modern humans spread from Africa across different regions of the globe and interbred with earlier descendants of H. heidelbergensis, H. rhodesiensis, namely the Neanderthals, Denisovans, as well as unknown archaic African hominins. See admixture, and see Neanderthal admixture theory. Use of tools and fire. The Paleolithic age of prehistoric human history and industry is dated from 2.6 million years ago to about 10,000 years ago, thus it closely coincides with the Pleistocene epoch of geologic time, which is 2.58 million to 11,700 years ago. The beginning of early human evolution reaches back to the earliest innovations of primitive technology and tool culture. They were the first to use fire to cook and made hand axes out of stone. Homo agaster used more diverse and sophisticated stone tools than its predecessors, where early Homo erectus used comparatively primitive tools. This is probably because H. agaster inherited, used, and created tools first of Oldowan technology and later advanced the technology to the Acheulean. Because the use of Acheulean tools began in California 1.8 million years ago, and the line of H. erectus diverged some 200,000 years before the general innovation of Acheulean industry in Africa, then it is plausible that the Asian migratory descendants of H. erectus made no use of Acheulean technology. It has been suggested that the Asian H. erectus may have been the first humans to use rafts to travel over bodies of water, including oceans. And the oldest stone tool found in Turkey reveals that hominins passed through the Anatolian gateway from Western Asia to Europe approximately 1.2 million years ago, much earlier than previously thought. Use of fire. East African sites, such as Chesawanya near Lake Baringo, Kubifora, and Oligosalia in Kenya, show potential evidence that fire was utilized by early humans. At Chesawanya, archaeologists found fire-hardened clay fragments, dated to 1.42 Maya. Analysis showed that, in order to harden it, the clay must have been heated to about 400 degrees Celsius. At Kubifora, two sites show evidence of control of fire by Homo erectus at about 1.5 Maya, with reddening of sediment associated with heating the material to 200 to 400 degrees Celsius. At a hearth-like depression, at a site in Oligosalia, Kenya, some microscopic charcoal was found, but that could have resulted from natural brush fires. In Gadab, Ethiopia, fragments of welded tuff that appeared to have been burned or scorched were found alongside H. erectus created Acheulean artifacts, but such re-firing of the rocks may have been caused by local volcanic activity. In the Middle Awash River Valley, cone-shaped depressions of reddish clay were found that could have been created only by temperatures of 200 degrees Celsius or greater. These features are thought to be burnt tree stumps such that the fire was likely away from a habitation site. Burnt stones are found in the Awash Valley, but naturally burnt welded tuff is also found in the area. A site at Benot Yaakov Bridge, Israel is reported to evidence that H. erectus or H. augusta controlled fire there between 790,000 and 690,000 BP. To date, this claim has been widely accepted. Some evidence is found that H. erectus was controlling fire less than 250,000 years ago. Also, that H. erectus was cooking their food as early as 500,000 years ago. Reanalysis of burnt bone fragments and plant ashes from the Wonderwork Cave, South Africa, has been dubbed evidence supporting human control of fire there by 1 Maya. Cooking. There is no archaeological evidence that Homo erectus cooked their food. The idea has been suggested, but is not generally accepted. It is known, from the study of use wear on hand axes, that meat formed a growing part of the H. erectus diet. But meat is digestible without cooking, and its use is not itself evidence of cooking. As nuts, berries, fruits, and grasses are also eaten raw, then cooking cannot be presumed. The issue rests on clear evidence from archaeological sites, which at present does not exist.